On my screen, we have the matching parts core project. This is the level of completion that we left off with last class. I believe we got to the modeling portion of it. So if I just double check a few things, the name or the initials have been created. If I go back to the instructions, let's see where we left off. So step 8, create the new coordinate system and name it first operation. Let's see, I'm just going in reverse. So step 6, I did create the letters. Step 7, I do have the bounding box that represents the material. And I do have the coordinate system at the upper right corner, bottom of part. So I did do all 8 steps, and we definitely saved our work. So we were moving on to the toolpath creation part of this project. Step 1 says make the toolpath manager visible and import a machine definition. So like the other projects that we've done together, go to the toolpath manager. If it's not visible on your screen, you'll have to go to the view tab. In the manager section, select toolpaths. And if you have any other managers visible, they'll be highlighted blue in this section, in the manager section. I've got my planes, levels, and I'm going to make the toolpath manager visible. You can currently see that I don't have anything inside of the toolpath manager. The brand new toolpath manager, empty. Let's bring in a machine definition. Go to machine. In the machine type section, you'll see mill, expand mill. And then for this project, select default. You'll see the default machine group placed in the toolpath manager. We're going to make some changes to it. Before I make any changes to the machine group, I'll go up to File. So from the File drop-down menu, I'll select Project Manager. And the project file folder, this is where the Mastercam file is currently saved to. I would like my NC files and my NCI files saved to this location. Now with the Home Learning Edition, you do not have the capabilities of creating these 2 types of files. This is something that you would want to do though if you were at work or at the school working on your files or working on your projects. So from here, I'll select OK. To get back to Mastercam, I'll select the back arrow. I can now go into the properties of the machine group. So inside the toolpath manager, under machine group -1, you'll see properties, expand it, select the plus sign. Underneath properties, select files. I'll start by changing the group name. I'll match the group name to whatever machine we happen to be running this on. I'll call this the Haas VF2. Once you change the group name, select edit. We're going to change the machine group's spindle capabilities. So where it says mill spindle group, expand it, select the plus signs until you see tool spindle. Once you see tool spindle, double click on it. Set the maximum spindle speed to 10,000. And if you were at work, you'd have to match whatever the machine is capable of doing. You'd enter that value into this field. From here, I'll select OK. That'll complete all of the changes that we need to make on this page. So I'll select OK again. And that'll take care of all the changes that we need to make to the first page. From here, go to Tool Settings. Default program number. This will be a 4 to 5 digit number of your choice. If you're programming for certain machines, you'll want to avoid certain numbers. In this particular case, we're programming for a Haas machine. Do not use 9,000 series numbers. Those are reserved for, I believe, Renishaw subroutines or Renishaw programs that are used to set origins and used for the OTS on the machine. So do not use 9,000 series number. So I'll call this 8,050. Just a number I chose randomly. Feed calculation. Select from material. From here, go to the toolpath configuration. We'll check assign tool numbers sequentially. We'll check warn of duplicate tool numbers, and we'll check use tools, step, peck, and coolant. Once you do that, go down to sequence number, set the start to 1, and then have the increments set to 1. For the material, if we look at the drawing, I'll go back to the project page and I'll look at the image of the drawing. It's saying make from 6.5. Well, here's the size, but they want us to make it from aluminum 6061-T6. So back inside of Mastercam, where it says material, current material is aluminum inch 2024. We'll start by selecting the correct material. I'll go to select. From the material list, don't have much to choose from, so I'll right click. From the flyout menu, I'll select get from library. And from here, I'll select aluminum 6061 or aluminum inch 6061. I'll select OK. I'll select OK again. And you can now see that the current material is aluminum inch 6061. Once I have the correct material selected, I'll select edit. For the material name, I don't need to have the inch in the name, but I will type in -T6. So 6061-T6. For the base cutting speed, I'll set this to 300. And that'll take care of all the changes that I need to make to this page. From here, I'll select OK. That'll complete all the changes for this page. Go to stock setup.
Doesn't the drill base speed need to be set to 50%?
Correct. So let's go back to that. I missed that. So I missed something. So go back to the tool settings, go back to edit, where it says percentage of the base. Left click on 60, hit enter, and now type in 50. So the actual SFM for drilling operations is 50% of the base SFM. So when we calculate our RPM, it's going to use 150 for the SFM. From here, I'll select OK. That'll complete all the changes on this page. Go to stock setup. The first thing I'll change where it says stock plane. Set this back to top and select OK. For the shape of the stock, now this is the stock that we're going to see inside of Verify. I'm going to use the solid model that we created that represents our material. So for the shape, I've got solid mesh. Once you activate it or select it, this icon becomes available to you. This will allow us to actually pick select whatever we have representing our material inside of Mastercam. So I'll select this icon. I'll go to the level manager. I need to make my material level visible. Now be careful. You want to select the material and not the part. So I'm actually going to roll or tumble my view. So if I select the material, that's what's going to define my material for Verify. I'll select display. I'll select solid. I'll select OK. And from the level manager, if I toggle off the visibility of the material, you still see a representation of the material. This material, you cannot select it. This is just a visual representation of what the material is going to look like inside of Verify. Once I verify that's the correct location, correct size, I'll toggle off the visibility of it with this icon right here. So tool paths, stock display, and that hides it. Got from an isometric view. From here, I can go back to the toolpath manager. Taking care of all the changes that we need to make. The one last thing I'll do before I start creating stock models and toolpaths, I'm going to change the toolpath group -1 name. I'll change the name of the toolpath group to first operation. To do that, couple different ways you can do it. The way that I like to do it, I'll left click on it. With it highlighted, I'll right click on it. From the flyout menu, I'll select groups, rename. And I'll call this one first operation. This would be a good time for me to save my work. The next thing that we'll need to do is we'll need to create the stock model that represents the raw material. So how's everyone doing?
Good.
Everyone's keeping up, no problems? All right.
Yeah.
Perfect. From here, let's start by creating the stock model that represents the raw material. This is done almost in the same way that we define the stock for verify. In this particular case, I'll go to the level manager. I'll make the material level visible. I'll go back to the toolpath manager. First operation toolpath group, currently nothing in it. I'll go to toolpaths. In the stock section, I'll select stock model. For the name, we'll call this raw material or raw stock. For the stock plane, I'll deselect it. I want it to read top. And for the initial stock shape, once again, I'm going to select the solid model that represents the material. So I'll select model. And when I do that, this icon becomes available to me. Left click on it. And once again, carefully select the solid that represents your material, not the solid that represents the part. Once you select it and selection, that should take care of the stock model for the raw material. We do not have a source operation for this first stock model. From here, I'll select OK. You see another stock representation appear on the screen. This time it's gray. If I go back to the level manager, I can toggle off the visibility of the material. And you can still see the gray stock model sitting on top of our part. If it's located in the right place and if it's the correct shape and size, you can go to the toolpath manager and you can toggle off the visibility of that stock model. So with it selected, select this icon here, toggle display. And that's how we'll toggle off the display of our toolpaths also. Anytime I create a stock model or toolpath, I like to save my work. So file save. And we're now ready to create our first toolpath. If I go to the project page, we'll take a look at the drawing. It says make from 6.5 by 4.25 by 1 inch thick aluminum. If I look at the dimensions on the blueprint, 6.5 is the overall length, so it's already to size. By 4.25, already to size. And 1, so it's already to size. So we don't need to machine the outside profile or the outside rectangular shape. We don't need to face the top of the part. But what we need to do is we need to cut out 1, 2 steps, and then 1, 2 pockets. Then we need a spot drill and drill, break the sharp edges with the chamfer mill, and then engrave our initials. And maybe not necessarily in that order, but let's see what we're instructed to do where it says creating toolpaths. So step 1, make the toolpaths manager visible and import a machine definition. Did that. Step 2, modify the settings in the machine definition. Did that. Step 3, use a contour toolpath to create the outside arc profile. So we'll start with the arc profile, and I'll show you what that is in a second. Tool 1, we're going to use a 1 inch diameter flat end mill, 3 flute. And it's telling us to use a tool projection of 2 inches. So we'll follow these instructions when it comes to when we have to define our tool. So I'll go back in the Mastercam. The arc profile is defined by that edge right there, or that's how you can identify it. We're going to use a contour toolpath. Go to toolpaths. In the 2D section, select contour. says wireframe chaining. For the mode, I have C-plane selected, and then the selection method is set to chain. I'm going to select this arc right here. So if I position my cursor over, you see it become highlighted. I'm going to favor this endpoint. And when I left click on it, you see all connected entities become selected and the chain is going in a clockwise direction. That's what I want. If for whatever reason it's going in the wrong direction, you can change the direction here, reverse. So chain's going in a clockwise direction. From here, I'll select OK. We'll start by selecting a tool. Currently, I don't have any tools added to my tool list, so I'll select library tool. My filter is active. You can see right here, it says filter active. There's a check next to it. It's currently looking at chamfer mill, so I'll select the filter icon. I'll start by deselecting all tool types. I'll select none, and then I'll select flat end mill. And for the tool diameter, I'll set it to equal and type in 1 and hit enter. So we're looking for flat end mills that are equal to 1 inch in diameter. I'll select OK. I've got one tool that fits that description. It's tool number 297 coming out of the library. When I double click on it, it's added to my tool list as tool number 1. Reason being is where it says tools or under tool settings, I have assigned tool number sequentially checked. So we added the flat or the 1 inch flat end mill to our tool list. We'll need to make some changes to the default settings. From the tool list, right click on the tool. From the flyout menu, select edit tool. For starters, we're instructed to set our tool projection to 2 inches. So I'll need to make some changes to the shoulder length. Set the shoulder length to 2. From here, select next. We're instructed or told that it's a 3 flute end mill, so set the number of flutes to 3. To calculate the RPM, you can select the calculator. To turn on the coolant, we'll select show more options, select coolant, and then set the flood coolant to on. From here, select OK. We're going to rough and finish with this tool. So where it says finish XY step percentage, set this to 2. And that should complete all of the changes that we need to make on this page. So from here, I'll select finish. In the speeds and feeds or the RPM and the feed rate area, you can see that the spindle speed has already been calculated. The feed rate, we need to calculate the feed rate. Let's set the FPT for this tool equal to 1% of the tool diameter. The decimal equivalent is up here. This one's an easy one to work with. It's 1 inch. So 1 times 0.01 is 0.01. And that's calculating my feed rate at 34.38 inches per minute. Let's set our plunge rate to half the calculated feed rate. So where it says plunge rate, I'll type in 34.38, divide that by 2. I've got rapid retract selected. In the tool name, I'm copying the tool name, paste it in the comment field, and then provide some type of useful information. So machine arc profile. And that'll complete all the changes that I need to make to this page. From here, go to the holder. If I look at the tool list, all the way at the bottom of the project page, we're instructed to use a C4 E3-1000. That is a Cat 40 tool holder. So instead of looking through this long list of tool holders, I'll go to the Cat 40 tool holder library. So I'll select open library. We're looking at the Cat 40 inch tool holder library. So select it, select open. And we're looking for a C4, let's see here. C4 E3. C4 E3-1000. Select it and then set the tool projection to 2. That'll complete all of the changes that we need to make to this page. Go to the cut parameters. Now, Mastercam is holding on to settings from the chamfer mill that we used on a previous project. At least it is for me. It might be different for you. Compensation type, set it to where. For the contour type, make sure it's set to 2D. So where 2D, stock to leave on walls, set this to 0. Stock to leave on floors, set this to 0. We could turn on depth cuts. I don't think it's going to influence or impact what we're doing, but we can turn it on. Lead in, lead out. I'm looking at my default settings. I've got 25% for line arc on the entry and line arc on the exit. Breakthrough. Make sure breakthrough is turned off. Multi-passes. We'll turn on multi-passes. I'm going to set the number of rough passes to 2. For the number of finished passes, I'll set this to 1. And then I'll leave the spacing at 20 thou. And that was calculated by, we set it to 2%, correct. So that was that 2% that we set for the XY step over percentage. That's where this information is coming from. For the finished pass, I'll select final depth. And then you'll match all of your settings to what I have here. These are, for the most part, default settings. From here, I'm going to go down to linking parameters. I want my clearance plane to be 2 inches above the top of the part. We need to remember that the origin is on the bottom of the part. So to set my clearance to 2 inches above the top of the part, I'll start by setting the value to absolute. I'll select the clearance icon. And then I'll pick select something that represents the top of the part. Now, when I do that, the value comes back as 1. I'm going to add 2 inches to this value. So select next to the 1 inch, type in +2 and hit enter. My clearance is 3 inches absolute, which is actually 2 inches above the top of the part. Remember, the origin's on the bottom of the part. I've got use clearance only at the start and the end of the operation checked. I've got retract. I'm going to turn retract off in this case. I'll set my feed plane to 0.1 incremental. Top of stock is 1 absolute. And for the depth, I have it set to absolute. I'll select the depth icon. And I'm going to pick the bottom of the arc profile. So I'll select it right here. Let my cursor lock onto this endpoint, left click. It takes the Z value from that location. And then I'm thinking that I'm going to turn my retract back on. And I'm going to set this to 1.1 absolute. I'm going to have it retract 0.1 inches above the top of the part. From here, I'll select OK. I'm looking at this toolpath and I'm thinking that we're not going to be cutting anything on this first pass. So what I would like to do, I would like to go back to the parameters, go back to multi-passes, and let's set the spacing to 0.375. So I've got 2 rough passes at 0.375 spacing. I'll select OK. I'll need to regenerate the toolpath group or regenerate the toolpath. That still might not be giving me what I need. Let's see what it looks like inside of verify. So, or we're running backplot first. I'm cutting a bunch of air. It's not doing much. So on this particular toolpath, we don't need two roughing passes. So instead of watching any more of this, I'll just exit out. I'll go back to the parameters where it says multipass, set the number to 1 and then set the spacing back to 0.5. Select OK. Regenerate the dirty operation. From here, we can run it in backplot. I'm not seeing any issues inside of backplot. So from here, we'll exit backplot. We can toggle off the visibility of this toolpath. Before you go into verify, I highly recommend that you save your work. From here, look at it from an isometric view. You might have to fit your screen. I'll select the entire first operation toolpath group, and then we'll go into verify. Once we're inside of verify, make sure that stop condition collision is turned on. I'll increase the precision a little bit and slow it down. Hit the play button. I'm not seeing any issues. I don't see any collisions. And I'm comparing the machined model to the wireframe model. And you can see how things are matching up. So I like what I see. So we can exit verify. Look at it from an isometric view. I'll save my work. What I'll need to do is I'll need to create a stock model that reflects what the first contour toolpath has done. Make sure the insertion arrow is at the very end of your toolpath group. Go to the toolpath section. In the stock section, select stock model. For the name, I'll call this arc contour or machine arc contour, just something that makes sense. For the initial stock shape, we're going to use the stock model or the stock model that represents the raw material. So I'll select stock model. I only have one stock model available, so raw material. And then for the source operation, select the toolpath or the contour toolpath that we just created. I'll select OK. You see the stock model appear. It's the gray shaded item. And once again, I like to inspect the stock model. I want to make sure that the stock model's edges match up with the wireframe representation of the part. And everything seems to be matching up. So from here, I'll toggle off the visibility of the stock model. Once again, I'll look at the project from isometric view, and I'll save my work. So we've created the stock model that represents the first operation. If I go back to the project page, and if we look at the instructions, we're moving on to step 4. Use a contour toolpath to create the rectangular boss feature on the part. I'll look at the tool list. And we're going to use that 1-inch flat end mill for the next contour also. So what I'll do is I'm going to copy the existing toolpath. I'm going to paste it at the insertion arrow. And then I'm going to make some changes to it so that this copied toolpath will work for the next toolpath or work for the rectangular profile. So with just the contour toolpath selected, there's a green check next to just this toolpath. right click. From the flyout menu, I'll select copy. Next to the insertion arrow, right click, paste. You need to be careful when you do that, otherwise you can copy all the stock models and it just becomes a big mess. So now that I've got the second contour toolpath pasted in my toolpath manager, let's start by updating the chain geometry or the chains that are driving the toolpath. If I select the geometry, you can see that the chain that's driving the toolpath is the chain from the arc profile. We're not going to use that one for this toolpath. So in the chain manager, right click, rechain all. It brings the wireframe chaining dialog box back. I'm going to select the top edge of the rectangular profile so that it's going in a clockwise direction. So I select right about here. You see all connected entities become selected. The chain is going in a clockwise direction. From here, I'll select OK. You now see the new chain. From here, I'll select OK. We'll need to make a few changes. If I go to the parameters, the tool, nothing needs to change here except for the comment. We'll say machine rectangle profile. Okay. From here, go down to cut parameters. We're just going to double check a few things. I don't need to change anything on this page. Depth cuts. You can leave it turned on. I don't think it's going to use it. Lead in, lead out. I'll use the default values. That looks good. Breakthrough. Once again, make sure that it's turned off. Multi-passes. This time, we will need to have 2 rough passes. So I'll set the number of rough passes to 2. Once you update that page, jump down to linking parameters. For the top of the stock, that will remain the same. What will change here is the depth. So depth is still absolute. Select the depth icon. This time, select something that represents the bottom of the rectangular profile. Once my cursor locks on, I left click. The new value is 0.62 absolute. From here, I'll select OK. I'll need to regenerate the toolpath. We made some changes to it, so I'll select regenerate all dirty operations. Now, just that contour toolpath selected, I'll run it in backplot. I'll select play. I'm not seeing any issues inside of backplot. So from here, I'll exit backplot. I'll save my work. Looking at it from an isometric view, I'll zoom out a little bit. Select the entire first operation toolpath group, and then select verify or go into verify. Stop condition collision is turned on. Slow it down a little bit. It was pretty quick last time. I'll select play. Once it's done running in verify, inspect the machine model, make sure that things line up. And you can see here, the machine model is pretty much lining up with the wireframe representation of the part. You can zoom in real close and things start to look a little choppy. That's just the limitations of your computer or your graphics card. So I can see here, I'm confident that things are lining up nicely. So once you verify that it's correct, you can exit verify. We'll need to create the stock model that reflects what the new contour toolpath has done. So insertion arrow is at the very end of the toolpath group. From the toolpaths tab in the stock section, select stock model. And the name, let's call this rectangular profile or rectangle profile. For the initial stock shape, we're going to use the stock model from the previous operation. So stock model selected, from the drop-down menu, select arc contour. Actually going to change this to rectangle contour just to be consistent. For the source operation, select the new contour toolpath and then select OK. Mastercam creates the stock model. And once again, I like to compare the stock model to the wireframe representation of the part or the solid representation of the part. Everything appears to be lining up properly. So from here, I'll toggle off the visibility of that stock model. And I'll save my work. So now I've created the stock model for the rectangle profile, the rectangle contour. I'm going to minimize the stock models and the toolpaths inside of my toolpath manager. That way I have more room and I can see everything that's being created. From here, I'll go back to the instructions for the toolpaths. We're moving on to step 5. It says use a pocket toolpath to create the rectangular pocket feature on the part. If I go to my tool list, we're going to change over to a 1/2-inch diameter flat end mill. And I could probably get by using this 1-inch flat end mill, get the job done a little bit quicker maybe. But we're going to follow the instructions here. On the other project, I believe we used on the matching parts cavity, we did use the 1-inch flat end mill. We're going to change it up and use a 1/2-inch diameter flat end mill for the rectangular and the circular pocket. We're instructed to use a C4E3-0500 tool holder, and we're going to set the tool projection to 1.5 inches. We're going to create a pocketing toolpath. Go to toolpaths. In the 2D section, expand the gallery and select pocket. Wireframe chaining dialog box appears. We're going to select the top edge of the rectangular pocket so that the chain goes in a counterclockwise direction. I'm going to select this inside edge right about here. Left click. You see the entire edge becomes selected and the arrow is going in a counterclockwise direction. That's what we want. So from here, I'll select OK. And real quick, if it's not going in the right direction, you can change the direction with this reverse icon right here. So counterclockwise direction, I'll select OK. We'll go to the tool. We're going to add a 1/2-inch diameter flat end mill to our tool list. Select library tool. Filter is still active, so I'll select the filter icon. I am looking for a 1/2-inch flat end mill or a flat end mill. But for the tool diameter, set this to 0.5 and then select OK. I do have one tool that fits that description. It's tool 290 coming out of the library. When I double click on it, it's added to my tool list as tool number 2. We'll make some changes to the default settings. So right click on the new tool. From the flyout menu, select edit tool. On the first page, we might need to change the shoulder length. Tool 3, it says shoulder length 1.5 inches. Or I'm sorry, tool projection 1.5 inches. So the shoulder length will work. So we don't need to make any changes to the default settings for this tool. So from here, select next. Let's start by setting the number of flutes to 3. We can calculate the RPM by selecting the calculator. And then to turn on the coolant, we'll select show more options. We'll select coolant. Then we'll set the flood coolant to on. From here, I'll select OK. This is another situation where we will be roughing and finishing with the same tool. So let's set the finish XY step percentage to 2% of the tool diameter. And that'll complete all of the changes that we need to make on this page. So from here, I'll select finish. The spindle speed we've already calculated. For the feed rate, let's set the FPT equal to 1% of the tool diameter. So take the decimal equivalent of the tool diameter, 0.5, multiply that by 0.01. Our FPT is 0.005, which calculates our feed rate at 34.38. Set the plunge rate to half the calculated feed rate. So 34.38 divided by 2. Rapid retract is selected. For the comment, I'm going to borrow the tool name from up here. And we'll say all caps, machine, angular pocket. And that'll complete all of the changes that we need to make to this page. For the holder, once again, this will be a Cat 40 tool holder. So let's open up the Cat 40 tool holder library. So CT 40 inch, I select open. And if you look at the tool list, this is going to be a C4E3-0500. So C4E3-0500. And we're instructed to set the tool projection to 1.5 inches. And that'll complete all of the changes that we need to make on this page. From here, go down to cut parameters. I've got direction set to climb, pocket type set to standard. These are just default settings that we're going to use. Stock leave on walls, I've set to 0. And stock leave on floor is also set to 0. From here, go to roughing. I'm using a parallel spiral. And I'm accepting the default values for step over, percentage and distance. From here, go to entry motion. I'm going to use a helical entry, set the minimum radius to 25% and set the maximum radius to 50%. And then select center on entry point. For finishing, I've got finish activated. Number of passes set to 1. Spacing, Mastercam is calculating that based off of the 2% XY step over percentage. And my cutter compensation, I've set to wear. Match your settings to what you see on my screen. Go to lead in, lead out, or lead in out. Once again, I'm using 25% for the line and arc on the entry and the line and arc on the exit. If you find yourself changing these values frequently, set them to what you would like them to be, and then select this icon here, save parameters. Depth cuts. This pocket might be 50% greater, or the depth of this pocket might be greater than 50% of the tool diameter. So let's activate depth cuts. I'm not going to have any finished cuts on the floor. Let's see here. Everything else looks good. Breakthrough on a pocket. Make sure that breakthrough is turned off. Linking parameters. We're going to use the same linking parameters, or at least the same clearance plane as we did for the first toolpath. So set the clearance to 3-inch absolute. I'm going to use clearance only at the start and the end of the operation. Retract. I'm going to set it to absolute and set my retract to 1.1. Feed plane, 0.1 incremental. Top of the stock should be the top of the part, 1-inch absolute. And then depth, I'll set it to absolute. And I'm going to use the depth icon to get back into Mastercam. And I'm going to pick select something that represents the bottom of the rectangular pocket. And relative to the origin, it should be 0.5 inches. From here, I'll select OK. I'm seeing a preview of what the toolpath will look like. Something that I'm seeing right away. I'm seeing the helical entry at the upper right corner of the pocket. What I would like for that to, I'd like that to be located at the center of the pocket. You'll remember that we checked center on entry point. We never specified the entry point. So what we need to do is we need to go back in and add a piece of geometry to the geometry. So underneath the pocketing toolpath, if you expand it, you'll see geometry. There's one chain. Select geometry. We're going to add a center point to this geometry. In the chain manager, right click. This time we will use add. Wireframe chaining dialog box appears. For the selection method, select point. And then position your cursor on the outer edge of the circular pocket. And what it's doing is it's locking onto the center. So it doesn't matter. The Z position doesn't matter. We're just telling it where in the X and the Y we want to center this helical entry. So I'll select the top edge of the circular pocket. You see the center point become visible. When you see that center point become visible, left click. Mastercam is creating a point there. From here, I'll select OK. That point has now been added to this list of geometry. I'll select OK again. We'll need to regenerate this toolpath. It's considered a dirty toolpath or dirty operation. So I'll select regenerate dirty operations. And now before I even run it in backplot, you can see that helical entry is now centered around that point. And that's what I want. With that toolpath selected, I can run it in backplot. I'm not seeing anything that's causing a problem. So from here, I'll toggle or I'll exit backplot. I'll toggle out the visibility of this toolpath. I'll look at it from an isometric view. I'll fit my screen. I'll unzoom a little bit. Before I go into verify, I want to save my work. To run verify, select the entire first operation toolpath group. I got green checks next to everything. Select verify. Inside of verify, make sure the stop condition collision is turned on, and then I'll select play. Once verify is complete, I'm inspecting the machined model to the wireframe representation of the part, and you can see the wireframe geometry pretty much lines up with the machined edges of our model. So from here, I'll exit verify, and I'll save my work again. What we'll need to do next is we'll need to create the stock model that reflects what the pocketing operation has done. Make sure the insertion arrow is at the very end of the toolpath group. From the toolpaths tab, in the stock section, I'll select stock model. For the name, I'll call this one rectangular pocket. For the initial stock shape, we'll use a stock model from the previous operation. And for the source operation, we'll select the pocketing toolpath that we just created. I'll select OK. Mastercam creates a stock model. And you can see that it's resembling the solid model of the part. We still need to machine the circular pocket, and we still need to spot drill and drill the holes that go all the way to the pocket. Once you verify that the stock model is correct, you can toggle out the visibility of it. And this would be a good time for us to save our work again. The next thing we'll need to do is we'll need to create the circular pocket. I go back to the instructions on the project page. We're on step 6. We just completed step 5. So use a pocket toolpath to create the circular pocket feature on the part. We're going to copy the existing pocketing toolpath and paste it, and then use the pasted version or the copied version for the circular pocket. Carefully, so I'm back inside of Mastercam, carefully select just the pocketing toolpath. You can see that there's a green check next to just that toolpath. Right click on it. From the flyout menu, select copy. Next to the insertion arrow, right click, paste. I'm going to expand the new toolpath. With the toolpath expanded, I'll select geometry. And you can see the point and the chain that this toolpath is currently using. I'm going to select chain 1. The point we can use for the next toolpath. So for chain 1, I select it, right click, delete. In the chain manager, right click, add. It brings up the wireframe chaining dialog box. This time I'm going to set it back to chain. So selection method, set it back to chain. I'm going to select the top edge of the circular pocket. We want this chain to go in a counterclockwise direction. I selected it, and you can see that the chain's going in a clockwise direction. So I'll flip the direction. I'll select reverse. Chain's now going in a counterclockwise direction. From here, I'll select OK. I'll select OK. I'll need to get into the parameters for this toolpath. So I'll select parameters. Now, a lot of these settings are already good, so we will just go through real quick and make sure that everything works. And if it doesn't, we'll make changes. So the tool remains the same. The RPM is good. The feed rate's good. Let's change the comment. This time we'll set it to machine circular pocket. The holder remains the same. Cut parameters remains the same. Roughing, don't need to change it. Entry motion, don't need to change it. Finishing, don't need to change it. Let's see here. Entry motion, lead in, lead out, don't need to change it. Depth cuts, good. Breakthrough, make sure it's turned off. Linking parameters. Top of the stock is now going to be the bottom of the rectangular pocket. So top of stock. I'm going to let my cursor lock onto something that represents the bottom of the rectangular pocket or the top of the circular pocket. And then for the depth, I'll select the depth icon. I'll let my cursor lock on to the bottom of the circular pocket. Relative to the origin, the depth is 0.3. So this all looks good. From here, I'll select OK. Because we made changes to the toolpath, we need to regenerate it. So I'll select regenerate all dirty operations. And now with just that toolpath selected, I'll run it in backplot. I'm not seeing any issues with the toolpath inside of backplot. So from here, I'll exit backplot. I'll save my work. I'll select the entire first operation toolpath group, and then I'll run it and verify. Inside of verify, stop condition collision is turned on. I'll select play. I'm comparing the machine model to the wireframe representation of the part. I think everything looks good. So from here, I'll exit verify. I'll minimize that new pocketing toolpath. With the insertion arrow at the very end of the toolpath group, I'm now going to create the stock model that reflects what this toolpath has done. From the toolpaths tab, stock model. Call this one circular pocket. The initial stock shape, we're going to use a stock model from the previous operation, rectangular pocket. And then for the source operation, select the new pocketing toolpath. Select OK. Mastercam creates a stock model. And once again, I'm comparing it to the wireframe representation of the part. Now it's getting more and more difficult to see because it's matching up with the solid model of the part. So I might have to toggle out the visibility of the solid model. And now all I'm seeing is the stock model and the wireframe representation of the part. And I can see that the bottom of the pocket matches up with the wireframe representation of the part. So from here, I'll turn the solid model level back on. I'll go back to the toolpath manager and I'll toggle off the visibility of the stock model. And this would be a good time for me to save my work. So now that we've machined all of the pockets, we're going to move on to drilling the holes. If I go back to the project page, we're on to step 7. It says use the drill toolpath to create the 0.375 diameter pilot holes in the part. If I reference the tool list, the next tool that we need to use is tool 3. It's the 1/2-inch diameter spot drill, 90-degree DPA or drill point angle. We're going to use a C3-0032 tool holder, and we'll set the tool projection to 1.5 inches. This will be a drilling operation. Go to the toolpath tab. In the 2D section, select drill. This will bring up the parameters for the toolpath hole definition. And it's asking us to select one or more entities. There's a bunch of different ways of going about selecting the geometry. I'm going to use this filter right here. So this icon, mask on arc, left click on it. Mastercam is now asking me to select an arc to match. I'm going to select this circle that represents the 0.375 diameter hole, left click. Now it's asking me to use window select, Control A, or the arc quick mask to find matching arcs. So Control A would work. I could window select the entire part, or I can come over to the quick mask icon right here. And this is the method that I like. Select this icon or the upper left half of it. it adds the 3 holes, or adds the 4 holes to the list. Something that I'm seeing before I even exit this page, these lines show us the order that the holes are being drilled, and the red point represents the first hole to be drilled. When I see yellow lines moving through part geometry, it gives me an idea that I might have a problem. So we'll just be aware of the clearance issue. So if we drill this hole and then move over to this hole, if we're not high enough above the part, we're going to run into the part. So that's not something we want to do. So we'll run it in backplot. We'll see what we get, and we might have to adjust. So from here, I'll select OK. Go to the tool. We're going to add a 1/2 inch 90-degree spot drill to our tool list. So I'll select library tool. The filter is still active. I'll select the filter icon. I'll deselect all tool types, and then I'll select spot drill. For the tool diameter, I'll set it equal to, actually in this case, I know there's only 4 or 5 spot drills coming out of this library, so I'll set it to ignore. And then I'll select OK. Let's see what we have. I've got 6 tools to choose from. So let's select the 1/2 inch diameter spot drill. It's tool number 24 coming out of the library. If I double click on it, it's added to our tool list as tool number 3. We'll need to edit the tool. So right click on the tool, select edit tool. Changes that I'll make on this page, the cut length. Set the cut length equal to half the tool diameter. So 0.5 times 0.5. Cutting length is 0.25. The shoulder length, set this to 1. And that will allow us to hold on to 1.5 inches of the tool. It'll allow us to set our tool projection to 1.5 inches. From here, I'll select the next. To get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. To calculate the RPM, select the calculator. To turn on the coolant, select show more options. Select coolant and then set the flood coolant to on. From here, I'll select OK. And then I'll select finish. Our RPM has been calculated at 1,146. To calculate the feed rate, set the FPT, think of it as feet per revolution. Set the FPT equal to 2% of the tool diameter. So here's the decimal equivalent of the tool diameter. 0.5 times 0.02, 2%. It's calculating my feed rate at 11.46 inches per minute. For the comment, this comment's actually carrying over, but I'm going to redo it. I'll borrow the tool name, paste it in the comment field, and then in all caps, drill all pilot holes. That'll complete all the changes that we need to make on this page. Go to the holder. Once again, this will be a Cat 40 inch tool holder. I'll go to the Cat 40 inch tool holder library. So I'll select open library. Cat 40 inch, open it up. And third one down, C4C3-0032. Select it and then set the tool projection to 1.5 inches. And let me double check that to the project page. So tool 3, yeah, 1.5 inch tool projection. So that'll complete everything we need to make, or everything that we need to change on this page. Go to cut parameters. The cycle should be a regular drilling cycle, 0 in the dwell value, or zero in the dwell field. From here, jump to linking parameters. Set the clearance to 3 inches. We're matching the clearance from the other operations. Set it to 3 inches absolute. Now, normally I would select use clearance only at the start and end of the operation. I know this is going to be a problem because we've got clearance issues with this rectangular wall. So I'm going to actually check this, but I'm going to set my retract. No, I'm not going to check that. Set the retract to 1.1 absolute. Top of stock. Set it to absolute. Select top of stock. And select the top of the 0.375 diameter hole. And then for the depth, I'll set it to absolute. I'll select the calculator. I'll select overwrite depth, and I'll set the finish diameter to 0.375. We're matching the finish diameter of the pilot to the finish diameter of the hole. From here, I'll select OK. Tip comp, make sure that it's turned off. And then I'll select OK to exit the parameters for this toolpath.
Wait, can you go back to the depth? I'm sorry.
Yeah, no problem. So top of stock, I've got to set the 0.625 absolute. And what I did, I just pick selected the top of the circular or top of the pot or top of the drilled hole. And then for the depth, I select the depth out. Well, first off, make sure it's set to absolute. I select the depth calculator. I'm setting the finish diameter of my pilot or my countersink to 0.375. And then Mastercam will calculate the Z value based off of this information.
Okay.
Make sure you have
Thank you.
overwrite. You're welcome. Tip count, make sure that it's turned off, and then I'll select OK. Now, something I'm seeing that I don't like, it's rapiding all the way back up to 2 inches above the top of the part before it repositions itself for the next hole. Let me see if I can fix that. I'll go to parameters. I'm going to check use clearance only at the start and the end of the operation. So it should go back to 1.1. I'll regenerate this toolpath. That looks better. You don't see the yellow lines moving through the part. If you see yellow lines moving through the part, especially if they're toolpath lines, be aware that you might have a collision. So from here, with just this toolpath selected, I'll run it in backplot. Select OK. Take one look at, I want to take a look at something stock. I'll experiment with this over the next couple of days. I want to see if we can get this to work properly because this could probably save us some time. So for now, just roll with what we have. I'll regenerate that toolpath. Everything looks good. I'll toggle off the visibility of it. Looking at it from an isometric view, I want to run this entire toolpath group inside of verify. So prior to that, I'll save my work. Select the first operation toolpath group. Everything has a green check next to it. And run it and verify. Once verify is done running, once again, I'm inspecting the machined model to the wireframe representation of the part. And in this case, you can see that the diameter of the pilot matches the diameter of the circle that represents the hole. And that's what we're shooting for. That's what we want. So that looks good. From here, I'll exit out of verify. We'll need to create the stock model that reflects what this spot drilling operation just did. So insertion arrows at the very end of my toolpath group. Go to toolpaths, stock model. For the name, let's call this one pilot holes. For the initial stock shape, we'll use the stock model from the previous operation. And then for the source operation, use the drilling toolpath that we just created. Mastercam creates the stock model. Everything looks good. From here, we'll toggle off the visibility of the stock model. Did not mean to do that. It went back into verify. We'll toggle off the visibility of the stock model. The next thing that we're going to do is we're going to use the existing drilling operation to drill the holes all the way through the part, but we'll need to make some changes to the copied version of the spot drilling operation. If I go back into the project page, we're moving on to step 8. Use the drill toolpath to create the 0.375 diameter holes in the part. I'm going to copy the existing drilling operation. Be careful with just the existing drilling operation selected. You see a green check next to just this toolpath. Right click, copy. Next to the insertion arrow, right click, paste. Expand the new toolpath. This time, the geometry that's driving this toolpath doesn't need to change. We're drilling the holes at the same location. So the existing geometry will work just fine. Go to the parameters. Go to the tool list. We're going to add a 0.375 diameter drill to our tool list. Select library tool. The filter is still active. I'll select the filter icon. I'll deselect any tool types that might be active. And then I'll select drill. For the tool diameter, set it to equal. And then in the value field, type in 0.375. And then select OK. We've got one tool that fits that description coming out of this library. So I'll double click on the tool. It's added to my tool list as tool number 4. We need to make changes to the default settings. So I'll right click on the tool. From the flyout menu, I'll select edit tool. On the first page, if I go back to the tool list, it'll tell us what our tool projection is supposed to be. So tool 4, 3/8 diameter drill. They're telling us to use a tool projection of 2 inches. To let Mastercam, or to get Mastercam to let us set our tool projection to 2 inches, we have to change the shoulder length. Set that to 2. And then select next. To get Mastercam to calculate the feed rates correctly, set the number of flutes to 1. Select the calculator to calculate our RPM. To turn on the coolant, select show more options, select coolant, and then set the flood coolant to on. From here, I'll select OK. And that'll take care of all the changes that we need to make to this page. I'll select finish. From here, the RPM has already been calculated, but the feed rate needs to be updated. Set the FPR, think of the FPT as the FPR when you're using drills, to 2% of the tool diameter. So here's the decimal equivalent, 0.375 times 0.02. It's calculated my feed rate at 11.46 inches per minute. In the comment field, I'll copy the tool name. I'll paste it down in the comment field. We'll say drill, all capital letters, drill all holes through. That'll complete all of the changes that we need to make on this page. Go to the tool holder. You look at the project page. Once again, we're instructed to use a C4 C3-0032. Tool projection is 2 inches. I'll go to the Cat 40 tool holder library, open library. Cat 40 inch, open it up. Third item down, C4 C3-0032. Set the tool projection to 2. That'll take care of all the changes that we need to make on this page. Go to cut parameters. Now we're just verifying that Mastercam is updated. It should have changed the cycle to peck drill. The peck increment, Mastercam has come up with this value for us. It's based off of the drill tip's length. I'm sorry, the drill's drill's drill tip or the drill tip length. So 1.1123 is based off of the 118 degree DPA. Linking parameters. We need to change the depth. Everything else should be good. So select depth. It should be absolute. Select the depth icon. Select something that represents the bottom of the part. Now remember, the coordinate system is at the bottom of the part. So the bottom part is Z0. We need Mastercam to, we need to guarantee, or we need to or the drill tip, the full diameter needs to go all the way through the part. So we're going to turn tip comp on. This graphic here is a good representation of what is going to happen on the machine. We want to make sure that the full diameter goes all the way through the part. Set the breakthrough amount to 0.025. And that should take care of everything for us. From here, I'll select OK. I need to update the new toolpath, or I need to regenerate the new toolpath. So I'll select regenerate all dirty operations. Now with just this toolpath selected, I'll run it in backplot. And right away, before I even run it, I'm tumbling my view. I can see that the toolpath goes all the way through the part. I'll select play. Everything appears to be okay. I'm not seeing the tool move through the part when it's repositioning itself. So from here, I'll select OK. I'll look at it from an isometric view. Before we run it and verify, we want to make sure that we save our work. To run it and verify, I'll start by selecting the entire first operation toolpath group. I'll select the verify icon. Inside of verify, make sure that stop condition collision is turned on, and then select play. Once it's done running the part or running the program or running the toolpaths inside verify, inspect the machined model. And in this case, I'm making sure that the drilled holes, the full diameter goes all the way through, and it does. So from here, I can exit verify. I'll save my work. And the next thing we'll need to do is we'll need to create the stock model that reflects what the new toolpath does. From the toolpath tab, in the stock section, I'll select stock model. For the name, I'll call this one drill holes through. For the initial stock shape, I'll set this, I'm using a stock model, and I'll use the stock model that we created from the previous operation, the pilot holes. And then for the source operation, I'll select the drilling operation that we just created. From here, I'll select OK. Mastercam generates the stock model. And we've gotten to the point where the stock model should match the solid model of the part. And you can see how everything lines up. Once you verify that it's correct, you can toggle off the visibility of the stock model. This would be a good time for us to save. So I'll look at it from an isometric view and I'll save my work. So now that we've drilled both holes or drilled all the holes, I'll go back to the instructions. So we're on step 9. Use the contour toolpath to create the engraved initials on the part. And if I look at the tool list, we're going to use a tool 5 will be a 1/32 diameter ball mill, 2 flute, and we're going to use a C4C4-0016 tool holder, tool projection 0.5 inches. Same setup, same tool as our previous projects. Before I engrave the initials, I'm going to make my name visible. I'm actually going to place this point on a different level. So where it says points, that's level 5. I'm going to place this point on level 5. I'll select the point. I can right click in the graphics area, and from the file menu, I can select change level, or with that point selected, I could go to the home tab, and where it says organize, I can select change level. I'm going to move it to level 5. So I'll deselect use active level. I can now enter a value into this field. I'll type in 5. I'll hit enter. And you can see now there's one item on the points level. If I make it invisible, I no longer have to look at the point, or the point's no longer visible. I'm going to engrave my initials. I'll look at it from a top view and zoom in a little bit. Insertion arrows at the very end of the toolpath group. I'm going to go to toolpaths. In the 2D section, I'll select contour. When we select geometry for engraving using a contour toolpath, the mode is set to wireframe. Select 3D. And then for the selection method, I'm going to use window. We're going to create a window around our initials. So I'll left click, drag my mouse. I'm creating the window, and I've got the window around my initials, and the initials need to be completely within the window. Left click. It doesn't look like anything has happened, but this prompt has changed. It says sketch approximate start point. I'm letting my cursor lock on to the bottom left of my first initial. When I see it lock into position, left click, and then all of the geometry that represents my initials becomes selected. From here, I'll select OK. And that brings us to the parameters for the contour toolpath. Now, when we engrave using a contour toolpath, we have to turn a bunch of things off. But before we even do that, let's select the tool. So I'll select tool. We're going to add that 1/32 ball mill to our tool list. Select library tool. The filter is still active, so I'll select filter. I'll deselect all tool types by selecting none. And then I'll select end mill to sphere. These are ball mills. This is what I usually refer to them as ball end mills or ball mills. For the tool diameter, we're looking for a very small tool, so I'm going to set it to less than 0.125. And this will show us all ball mills coming out of this tool library that are less than 0.125 in diameter. I select OK. I've got 3 tools to choose from. I'm going to select the 1/32 ball end mill, double click on it. It's added to our tool list as tool number 5. I'll need to make some changes to the default settings. So right click on the tool, select edit tool. The first thing I'll change is the overall length. Set the overall length to 1. And that'll be the only change that we need to make on this page. So from here, I'll select next. For the number of flutes, set it to 2. To calculate the RPM, select the calculator. To turn on the coolant, select show more options, select coolant, and then set the flood coolant to on. From here, I'll select OK. And that'll take care of all the changes that we need to make to this page. So from here, I'll select finish. The RPM, you can see, has been calculated. It's maxing out at our machine's maximum capabilities. For the feed rate, we'll need to calculate our feed rate. Set the FPT equal to 1% of the tool diameter. Here's the decimal equivalent of the tool diameter. So 0.03125 times 0.01. That's calculating my feed rate at 6.25 inches per minute. I'm going to set the plunge rate to half the calculated feed rate. So 6.25 divided by 2, hit enter. So my plunge rate, my feed rate, we've updated those. I've got rapid retract selected. In the comment field, I'll borrow the tool name. I'll provide some type of useful information. I'll say engrave, all caps, initials. And that'll complete all of the changes that we need to make on this page. From here, we'll go to the holder. This is a Cat 4D tool holder. So I'll go to Open Library. I'm looking in the Cat 40 tool holder library. So CT40-IN. This is a C4C4-0016 is a Cat 40 ER16 tool holder. Set the tool projection to 0.5. From here, go to cut parameters. When we use a contour toolpath to engrave our initials with the 2D geometry that represents our initials, I want the center line of the tool to follow the geometry that's driving it. To do that, we have to turn cutter compensation to off. So compensation type, set it to off. Contour type is 2D. Stock to leave on floors is 0. Now I'm going to go through several of these other items and turn them off. So depth cuts, we're only engraving 5 thousandths deep. So let's turn this off. Lead in, lead out, turn this off. Breakthrough, turned off. Multi-passes, turn it off. And tabs we don't use, so those are turned off already. Linking parameters. Now, a lot of these values are carrying over from the other contour toolpaths that we created. Feed plane, 0.1 incremental. Top of stock, this will be the bottom of the circular pocket. So I'll select top of stock. I'm letting my cursor lock on to the bottom of the circular pocket. The depth, I'll have this set to absolute. I'll select the depth icon. I'll let it lock on to the bottom of the circular pocket. And then to tell it to engrave 5 thousandths deeper, I'll select next to the value, minus 0.005, hit enter. And I think I put in minus 0.002. So it should be 0.295 absolute. And that'll complete all of the changes that we need to make to this toolpath. I'll select OK. I'm looking at the toolpath. I don't see any major issues. So with just that toolpath selected, I'll run it in backplot. Once you verify that there are no issues, exit backplot and toggle off the display of the toolpath. Before I run the entire toolpath group inside of verify, it's a good idea to save your work. I'll select the entire first operation toolpath group and then I'll run verify. Inside of verify, make sure that stop condition collision is turned off. I'm sorry, make sure that stop condition collision is turned on. Once the part is done, or once everything is done inside of verify, I'm inspecting the machined model. And this time you can see that the initials have been machined into the bottom of the circular pocket. And you can see that the engraving is centered on the wireframe geometry that's been used to define our initials. So that looks good. From here, I can exit out of verify. I'll save my work. And the next thing we'll need to do is we'll need to create the stock model that reflects what this engraving operation has done. Insertion arrows at the very end of the toolpath group. From the toolpath tab, stock model. For the name, I'll call this engraved initials. For the initial stock shape, we'll use a stock model from the previous operation. And then for the source operation, we'll select that contour operation or the contour toolpath that we just created. I'll select OK. Mastercam generates the stock model. Now it's not easy to see because the stock model is sitting on top of the solid model of the part. If I go to the level manager and toggle off the visibility of the solid model, you can now see the initials engraved into the bottom of the circular pocket. Once you verify that the stock model is correct, I can bring back the solid model. And then inside of the toolpath manager, I'll toggle off the visibility of the stock model. And this would be a good time for me to save my work. So now that we've engraved our initials into the part, we're going to, I believe we're going to break all of the sharp edges that were created from any of the toolpaths for this project. So if I go back to the project page, step 10 says use a contour 2D chamfer toolpath to break all sharp edges on the part. To do that, make sure that the insertion arrow is at the very end of your toolpath group. This will be a contour toolpath. Go to toolpaths, 2D, contour. Brings up the wireframe chaining dialog box. Set the mode to wireframe, select C plane, and then for the selection method, select chain. We're going to select 1, 2, 3, 4, 5 edges. And the majority of them have different Z values or are at different Z levels. All the external edges need to go in a clockwise direction. All of the internal edges need to go in a counterclockwise direction. I'm going to start by selecting this edge right here. And I'm going to select it closer to this endpoint. So I select this edge, the chain goes in a clockwise direction. I'm now going to select this edge and I'm going to select it closer to this endpoint. And once again, this chain is going in a clockwise direction. I'm now going to select this edge and the chain goes in a clockwise direction. So those are the 3 external edges. They all need to go clockwise. I'm now going to begin selecting the internal edges. I'm going to select this edge closer to this endpoint. Left click. The chain is going in a counterclockwise direction. And now I'm going to select this circle right about here. And this chain is going in a counterclockwise direction. Once again, as you select each chain, you got to handle them on an individual basis. As you select each chain, if it's going the wrong direction, you have to flip the direction. Then move on to the next chain. So from here, I'll select OK. And that brings up the parameters for this toolpath. For the tool, if I look at the tool list, we're instructed to use, let's see here, we'll go down to the very bottom. 1/4-inch diameter chamfer mill, 90-degree, included angle, 2 flutes. Tool holder will be a C4 C3-0032, and the tool projection will be set to 1 inch. So we're going to add a tool to the tool list. Select library tool. The filter is still active. I'll select the filter icon. I'll start by deselecting any tool type that might be selected. And I'm going to use a chamfer mill, not the spot drill, but the chamfer mill. And if I set the tool diameter to ignore, it's going to show us all tool diameters or all chamfer mills that are coming out of this library. I'll select OK. There's only 4 to choose from. I'll select the 1/4-inch chamfer mill. Double click on it. It's added to my tool list as tool number 6. I'll make some changes to the default settings. So right click, edit tool. On this page, I'll set the tip diameter to 0.01. This is what resembles, or this is what the tools that I have, the tools that I have at work have this tip diameter. From here, I'll select next. Set the number of flutes to 2. To calculate the RPM, I'll select the calculator. To turn on the coolant, I'll select show more options. I'll select the coolant icon, and then I'll set the flood coolant to on. And then I'll select OK. From here, I'll select finish. For the FPT, set this equal to 1% of the tool diameter. So 0.25 times 0.01. My feed rate's being calculated at 22.92. For the plunge rate, set it to half the calculated feed rate. So 22.92, divide that by 2. In the comment field, I'll start by copying the tool name. I'm going to provide some type of information. Once again, all caps in the comment field. So break all sharp edges. From here, go to the holder. We're looking for a Cat 40 ER32 tool holder. So go to Open Library. Select the Cat 40 tool holder library, open it up. C4 C3-0032, and then set the tool projection to 1 inch. From here, go to cut parameters. We need to turn cutter count back on. So set cutter compensation or compensation type to where? Contour type, set it to 2D chamfer. I'm going to leave the chamfer width at 0.005. And then I'll set my bottom offset to 0.025. So chamfer width 0.005, bottom offset 0.025. I'll accept the defaults for all the other settings. Now this is a very light cut. We're only taking 0.005 off the corners. We're just breaking the sharp edges. I don't need depth cuts. I'll leave that off. Lead in and out. Let's turn this back on. Breakthrough. I have it turned off. Multi-passes. Once again, this is a very light cut, so I'm not going to use it. Linking parameters. I'm going to use most of the values that the previous tool paths we're using. The one thing that I'm going to change is the top of stock and the depth. We have selected 5 different chains using different Z levels. Set the top of stock. I shouldn't have done that. Set the top of stock to 0 incremental, and then set the depth to 0 incremental. And what that does is it tells Mastercam to determine where it positions the tool relative to the chains, the different Z levels of the chains. From here, I'll select OK. I'm inspecting the toolpath. I want to make sure that the tool or the toolpath leads in off of the material. You don't want the tool inside the material when it approaches the chain that it's driving it. So everything appears to be correct. I'll run this toolpath in backplot. I don't see any issues, so I'll exit backplot. I'll toggle off the display of this toolpath. Before I go into verify, I look at it from an isometric view, and I like to save my work. From here, select the entire first operation toolpath group, and then run it and verify. Now this time, because I'm using a chamfer mill and I'm creating a very small chamfer, I like to turn the color loop on. So go to verify. So I'm inside of verify, select the verify tab, select color loop, and then select play. And now if I zoom into the chamfers, you can see the green surface that was created by the chamfering operation. And we broke all sharp edges that were created from these tool paths. If I wanted to, normally, if you were to turn this project into me, you would save the final machined model as an STL file. To do that, you would go to the verify tab, save stock as STL, save it to your working folder. So this would be matching parts core, we call it finished part. This will take a moment to save. Now you can go back in the Mastercam and do work inside of Mastercam while this is going on in the background. I normally don't like to do that. In this particular case, I am going to do that. So I'll go back in the Mastercam. Looking at it from an isometric view, I'll save my work again. If I go back to the project page, we just completed step 10. Step 11, create the NC file using the post selected operations icon. Not required with the home learning edition of the software. So once again, you guys have the home learning edition of the software at home. You cannot create the NC files. I'm going to demonstrate that just so you know how to do it. So inside of Mastercam, with the entire first operation toolpath group selected, I've got green checks next to everything. I'll select the G1 icon, post selected operations. I'm going to create the NC file. I can also create the NCI file. I'll select OK. Make sure that they're being saved to the correct location. So matching parts core folder, that is correct. And once again, this is the NC file. It's being saved to the correct location. I'll select save. And then once you save that NC file, it's going to open up Code Expert. This is the NC editor for Mastercam. And from here, we'll be able to view the NC code. You could make changes inside of the Code Expert. You can alter the NC code. Unless you're very good at doing that, I don't recommend doing it. So here we're seeing what Mastercam has done. Mastercam has taken the graphic representation of the toolpaths that you see here and converted them to a language that the machine understands. And this is all the G&M code that the machine needs to run the part or run the toolpaths that we just created. So from here, I'll exit the code expert. The last thing that I would do if I was turning this project into me is I would right click, setup sheet. This would be matching parts core. For the programmer, put your name, customer. You can put San Diego City College. I'll select OK. It's going to create the setup sheet. Takes a moment to open up. And while I'm here, I can exit out of verify. There it is. So here's the setup sheet. It's in the active reports viewer. If you scroll through it, it's got a bunch of useful information that we can send out to the shop. We need to save it as a PDF. So go to File, Save As, Portable Document Format. Once again, save it to your working folder. And I'll call this Matching Parts Core. Save it. And the last thing that I would do is I would just double check to make sure that everything is saved in the correct location. So there's my PDF of the setup sheet. I've got my NC file, my NCI file. Here is the Mastercam file. And here is that STL file that we created. To zip those up, I would just right click. I would go to 7-zip. Add to matching parts core zip. You'll see the zipped up file appear down here. And this is the file that I would upload to Canvas if I were turning it in. So from here, I'll exit the File Explorer. I can exit the Active Reports viewer, and I'll save Mastercam one last time. And that will complete the Matching Parts Core project.